Hi students, in this video we're going to look at the least squares regression, and in particular how to use the formula to determine its equation. Alright, so after watching this video you should be able to determine the equation of the least squares line for a data set using the formula. Okay, biggest things to remember, Pearson's correlation coefficient, so it's a good measure of how closely a data set is associated or correlated. And then also the least squares line, right? Better known as the line of best fit. It's our simplest model for our line of best fit. And we've talked about how to use your calculator to determine that equation based on some bivariate data. All right, so the formula we'll use are these two here. So note that we've got values for A and B. So looking at our line here, B is actually our gradient, so that's really M. A is our y-intercept. Let's put it in here. So with those use different letters. This is what's in your textbook, this is what's in your formula sheet. So it's good to get to know these ones. Just a tip, when you're using your Texas Instruments, remember that A is actually the gradient and B is the y-intercept. But make sure you do that switch when you're using your calculator. But your formula sheet on your exam actually looks like this, A plus bx. Now the formula for these is, so B, the gradient of our least squares line, is our correlation coefficient times by our standard deviation of y divided by our standard deviation of x. And then from there we can also work out our A value, our y-intercept. So our y-intercept is what our average of y minus b times our average or our mean of x. Alright, so now let's use the data we've been given here to answer some questions. So we've got the R value, our two standard deviations, and our two averages for x and y, explanatory and a response variable. And now we have to, first of all, to describe the association between the variables. Well, let's going to come back to our R value. So 0.8, that's strong. It's negative, so negative association. And finally, for the very fact we're using a least squares line and using Pearson's correlation coefficient, we can also say it is linear as well. So there's our association, strong, negative, linear association between our two variables. Right, now, our second step is to determine the equation of our least squares line. So we always start off with B, so B is our gradient, and our formula is Pearson's correlation coefficient from standard deviation of y divided by standard deviation of x, which equals negative 0.8 times 6 over 12. 6 over 12 is half, so half of negative 0.4. Sorry, negative 0.8 is negative 0.4. So there's our gradient. And once again, students, you can use a calculator for this aspect by subbing in the numbers and then just typing it straight in. That's more than okay. Then for A, it's our mean value for y minus m times our mean value for x. The mean for y is 28 minus our m value, or that should be our b value. Our b value is negative 0.4 times by our x, our average for x, which is 20. Okay, which equals 28 plus negative 0.4 times 20 is 36. So therefore our equation is y equals 36 minus 0.4x. So for this one, students, we're given all the information up here, and basically we just need to substitute it in to our formulas that are on our formula sheet to get our values for B and A. Alright, students, after watching this video, you should be able to determine the equation of a least squares line using the formula.